Hello, welcome to section 6.3, polynomial functions. A polynomial in one variable. A polynomial of degree n in one variable x is an expression of the form a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus dot 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 all the way to a sub 2 x squared plus a sub 1 x plus a sub 0, where the coefficients a sub n minus 1, a sub n minus 2, and a sub n minus 3 all the way to a sub 0 represent real numbers, and a sub n is not 0, and n represents a non-negative integer. This chain of terms is essentially a general representation of various terms in descending order of exponents. The degree of a polynomial in one variable is the greatest exponent of its variable. The leading coefficient is the coefficient of the term with the highest degree. A polynomial function. A polynomial function of degree n can be described by an equation of the form p of x, which is equal to a sub n x to the n plus a sub n minus 1 times x to the n minus 1 plus dot 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 all the way to a sub 2 x squared plus a sub 1 x plus a sub 0, where the coefficients a sub n minus 1 and a sub n minus 2, a sub n minus 3, all the way to a sub 0 represent real numbers. A sub n is not 0, and n represents a non-negative integer. Which leads us to example 1. What are the degree and leading coefficient of 3x squared minus 2x to the fourth minus 7 plus x to the third? So the directions tell us to rewrite the expression so the powers of x are in decreasing order or descending order. So we start with negative 2x to the fourth because that is the highest exponent. The next highest would be x to the third, and then the next 3x squared, and then your final term would be your constant, negative 7. This is a polynomial in one variable. In other words, only x is represented. The degree is 4 because that is the highest exponent, and the leading coefficient is negative 2, as you see here. So example 2. Find f of negative 5 if f of x equals x to the third plus 2x squared minus 10x plus 20. So you have your original function. This is a cubic. You have then f of negative 5, where plugging in negative 5 for x gives you this. Make sure it's in parentheses. Negative 5 to the third plus 2 times negative 5 in parentheses squared minus 10 times the quantity negative 5, still in parentheses there, and then plus 20. Therefore, if you do the math, you get negative 125, 50, 50, and 20. If you simplify then, you get negative 5. Example 3. Find g of a squared minus 1 if g of x equals x squared plus 3x minus 4. So the original function is there. Simply plug in a squared minus 1 in for x. So a squared minus 1 in parentheses squared plus 3 times parentheses a squared minus 1 minus 4. Now, in the next step, the math that follows is taking a squared minus 1, which I'll write here, and because it's squared, we're going to FOIL a squared minus 1 times a squared minus 1. In this case, it becomes first a to the fourth, a squared times a squared that is, outside negative a squared, inside negative a squared, and last 1. We have like terms of negative a squared and negative a squared, which add to negative 2a squared. Therefore, your trinomial is a to the fourth minus 2a squared plus 1. Then with this particular binomial, we distribute the 3, so that becomes plus 3a squared minus 3, and then of course still minus 4. Collecting like terms here and here, but also here and here, leads to the following: a to the fourth plus a to the second minus, underline one other like term here, so minus 6. So that, technically, is your final answer. Okay, on to the exercises. So, state the degree and leading coefficient of each polynomial in one variable. If it is not a polynomial in one variable, explain why. So number 1. So with this particular example, we can see that we have 3x to the fourth plus 6x to the third minus x squared plus 12. All of these terms are nice in that you see the highest degree, 4, the highest exponent, which is the degree, 4, but all the respective terms are descending as far as the exponent goes, or in decreasing order, we can say. And furthermore, all of these terms have just an x, except for, of course, the last term or the constant term, which is fine when it comes to looking at any polynomial. So as it turns out, this is a very nice fourth degree function. So let's go ahead and write our degree. Okay, the leading coefficient, I'll use the letters LC for leading coefficient, is 3. Again, the number in front of x to the fourth there. And we've pretty much answered this entire problem here. We've got the two things that we were asked to find. It is a polynomial, and we're ready to move on. So let's take a look at another problem. For example, number 3 here. Number 3, so we have got 4x to the 6th plus 6x to the 4th plus 8x to the 8th minus 10x squared plus 20. Clearly these terms are not in the descending order of exponents that we like to observe, or decreasing order, in other words. However, it does turn out that if we rewrote it, we would see the very first term, 8x to the 8th, be obviously out in front. So whether I rewrite this polynomial or not, I'm going to be able to highlight two things: the leading coefficient and the degree. Looking at the leading coefficient here of 8 and the degree 8, and with respect to the fact that none of these terms have anything but an x, with the exception of the constant, we can definitively say that this is in fact a polynomial. Let's take a look at a problem like number 4, however. Number 4, you have 4x to the second minus 3xy plus 16y squared. Okay, so there are two concerns here. Number 1, you actually have in the middle here, you have two variables. You have x and y. Furthermore, you have a third term, the third term technically in this function, being a 16y squared, which suggests, if we're looking at this, that we are missing an x. So I'll circle that as well. So because we don't have just one single variable in the problem, we can say that this is not a polynomial. Okay, on to number 7. Find f of 2 and f of negative 5 for each function. So f of 2, f of negative 5. So when it comes to evaluating at an x value of 2, we are going to substitute into 4x, and as you can see I put it in parentheses. Similarly with -5, plug it in parentheses. So then 2 squared, of course, 4, minus 9, -5. -5 quantity squared, 25, minus 9, 16. Now if I took the time to check this on my calculator, let's go ahead and do that. So I can go ahead and hit 2, store as x, and hit enter. So anytime you hit the X button, you'll get 2. And then we can actually type in x squared minus 9. And yes, that should give us the value we anticipated, -5.